Right, hello grade 11s. We're proving identities and we're just using all the things that we've been using so far, and that's it, except we're going to prove something that's given to us. Now, I want to make sure we're just on the same page of what we're trying to do here. We're given something like this in example 10, so I've purposely chosen something from the textbook so you can see it there as well. And we don't know that this is true, we need to prove it's true. So we're given something that's saying this left-hand side equals the right-hand side. That's what we need to prove. We don't know that it's true, so we can't start going, oh, well, that's fine. Well, if we add sine squared, no. So what I mean to say is this is not like you're given an equation that says x plus 3 equals 4, so I'm going to minus 3. That's not what we're doing. We don't know that this is true. We need to prove it. So how are we going to do that? We're going to pick one side and we're going to show that it equals the other side. So I'm going to cross out the right hand side to go, let's just forget that that's the case. And we're going to pick out this left hand side. And through a number of steps, what we need to do is show that eventually it looks the same as the right hand side. So we're looking at the left hand side, so it's quite nice to just start off by saying that's the side we're looking at. And let's just write it here. Tan squared theta minus sine squared theta. That's it. That's what we give. We don't rewrite the whole equation. Now we need to simplify this. And to do this, we're going to need... Oh, things got blurry there. To do this, we're going to need a few tools in our toolbox. So let's have them at the ready. We need our trig identities. And let's write those. I think it's useful to write them at the beginning of your test or exam, or if you're sitting down to do your worksheet, just write them out. Get them from your head and get ready to go. So the first one we know is that tan theta, so let's give ourselves some space here to write this. Tan theta, what's another way of writing tan theta? Okay, so we've got sine theta over cos theta. So at some stage we might want to change this tan theta to sine theta over cos theta. And our other fundamental trig identity we know is that what two things do you add together to get 1? Well, we've got sine squared theta plus cos squared theta. So those are our two fundamental trig identities that it is worthwhile writing down. We're not going to write down all those myriad of sine 180 plus sine 180 minus theta, all of those would work out as we go along. But for these two, we're going to write them down. And then one more thing that's useful to write down. Let's manipulate the second identity so that we've got it ready to sub in a different way. So this we could change to, if we subtracted sine squared theta from each side, then we wouldn't have it on the left hand side. We'd just be left with cos squared theta equals 1, and we said if we subtract it from the left, let's subtract it from the right hand side. So it's not a new identity, but it's a useful one. So if ever you see cos squared theta, we can replace it with 1 minus sine squared theta, or vice versa. We could replace 1 minus sine squared theta with cos squared theta. Okay, and the other one that we're going to do, and I know what I'm anxious to do is get into the question, because then we can see what I'm talking about here. If we subtracted from this trig identity cos squared theta, we'd just be left with sine squared theta on the left hand side, and on the right we've got this 1, and we've subtracted cos squared theta. So if ever we see 1 minus cos squared theta, we can replace it with sine squared theta. Now, hint, look ahead here, look, there's a sine squared theta. We're going to be using this one. I'm just giving you a heads up that we are going to use this, and we are going to use this. Okay, so you've got those 4 things written down. Beautiful. Now we're ready to go. So tan squared theta, we don't necessarily know where we're going to get to. So we're going to do a lot of substitutions and then hope that we get there. Now you might see the end before you get to it, and that's great too. So we're going to start by going tan squared theta. We've got another way of writing tan theta. We can write it as sine theta over cos theta, which means if we square this side, we can square this side. So tan squared theta I'm going to rewrite. So this is equal to sine squared theta over cos squared theta. And excuse my bad handwriting. I think it's because my hands are a bit cold. Okay. As I said, I don't know how this is going to get us back to this right-hand side, but if we see tan, it kind of makes sense that we'll replace it with sine over cos, probably. Then we're subtracting, and sine squared theta, I mean, we could replace this with 1 minus cos squared theta, but I'm actually just going to leave it in this case. Sine squared theta. You could probably get to our answer if you replaced it. Equals. We've got a fraction here. What can we write this over so that we've kind of turned it into a fraction? Yeah, we could write it over 1. So what's our lowest common denominator? Well, it's just cos squared theta. So we've got cos squared theta, and this stays as sine squared theta minus sine squared theta. What do we still have to multiply this sine squared theta by now? Well, yeah, by cos squared theta. Cos squared theta. Now, just as a reminder and a link to how we've solved these types of things before, why can I not just cancel these two out? I don't know how you would have put that, but I always think there are 2 terms on top and only 1 at the bottom, so you can't cancel when you've got 2 terms. Okay, so when we did this before, we said, okay, that's fine. How do we turn 2 terms into 1 term? We factorized. So let's factorize here. There's a common factor staring at us in the form of sine squared theta. Okay, sine squared theta. Sine squared theta times what gives you sine squared theta? Sine squared theta times what gives you the second term? I'm not going to do it as a question. There it is, minus cos squared theta. And now let's look at some things here. Sine squared theta over cos squared theta. I feel like we know what this was. We've used that kind of identity. We used it at the beginning. So I'm going to put it back in green and say, let's kind of work backwards here to say this bit I'm going to replace with tan squared theta. And here's why I'm looking back at the question and going, hey, look, I've got tan squared theta. I must be almost there. What do I need to multiply it by still? So we know what our outcome should be. We know that we need to still multiply it by sine squared theta. So in other words, does this bit, can I just write that as sine squared theta? Yes, yes, and yes again, because 1 minus cos squared theta equals sine squared theta. So we've got this on the right or the top of our page. Before we've even started our work, we've gone, now 1 minus cos squared theta. I'm sure I saw that somewhere. There it is, 1 minus cos squared theta, sine squared theta. So I'm just going to replace that with sine squared theta. Oh, tan squared theta, sine squared theta. Great stuff. This is equal to our right-hand side. So in other words, what we've shown is that the left-hand side equals the right-hand side. So just as a last bit, let's recap what we did. What we're trying to do is prove that whatever we're given on the left-hand side equals the right-hand side. And how we're going to do that is we're going to do this manipulation. Now it could be that you get given tan 180 plus theta. And then you change that into, okay, is that tan theta or negative tan theta? And you've got your cast diagram, and we've done that. In this case, we've used our fundamental trig identities. Useful to write them out, so you've just got them there for reference. You write down the first one, tan theta equals cos theta, sine theta over cos theta. Our second fundamental trig identity is that sine squared theta plus cos squared theta equals 1. And while we're at it, we quickly manipulate this equation so that we've got cos squared theta equals 1 minus sine squared theta, and sine squared theta equals 1 minus cos squared theta. These two aren't two that we have to remember as well. We derive them from this. So we just said take this, subtract the sine squared, there it is, subtract the cos squared, there it is. Reason being, now we've got them there for reference. You're going to be using and needing a few of these, so it's worth putting that time in to do. Then we go to our equation and go, let's pick a side. Pick the more complicated side generally. So let's pick the left-hand side and let's do a bunch of manipulations and make it look like the right-hand side. You could have picked the right-hand side, done some manipulations, and made it look like the left-hand side. So what I see here is tan squared theta. If I had taken the right-hand side, I might have said tan squared theta is sine squared theta over cos squared theta times sine squared theta, which I might have replaced. It feels like more of a mess than this one here. We had two terms, so you could do something with it. It's a difference of two squareds. You might have said this side was tan theta minus sine theta, tan theta plus sine theta. Many ways to do it. The point is that in the end, they're equal to each other. Okay, so good luck, and I wanted to write down which questions I want you to do, and that is exercise, exercise 7.8, we're on page 200, and there were 3 I want you to do. Of course, please do more if you want to, but I know the last one was J, and I wrote down the other one was G. Okay, now these require a bit of work, and you're just going to be going through these steps. So this is what we're doing today, Monday, into Tuesday, tomorrow. Bring your questions to class. We'll go through them on the Google Meet, and then we'll see how we're doing. Wednesday, we can start getting into, I think, practice for another day, and then Thursday we've got our tutorial. I'm going to give you an Ed puzzle on general solutions.